right, welcome back. This is Andy, and hopefully you guys know what you're tuning in for.
Yes, more of those same played out jokes about Larry's spicy goodness.
You know, I got nothing else in my life. Man's got to eat.
We got to get some new material, man.
But I love that spice.
What about other spices? Like holiday spices, like cinnamon and clove and nutmeg.
And is that Christmas bells I hear? Holiday bells? Maybe. Happy holidays for those folks that are listening to us right as this episode drops. Otherwise, these beautiful jokes about sweet nutmeg will probably make a lot less sense.
Yeah, I use nutmeg more than just Christmas time.
So you're not a part of the No Nutmeg November gang?
Hell no.
Well, that's unfortunate because it is November as we record this. Me and my No Nutmeg November are just going to be real sad and disappointed that we're all alone.
Yeah, salty, like Lowry's.
In this episode, we're not going to be talking about Santa, wait for it, Bacaw, like, Santa Claus.
Santa Cluck?
Nah, man, you got to sell it.
You wrote this joke, it's terrible.
You wrote this joke. But speaking of those Santa Bacaws, let's talk about free-ranging our landscapes to find minerals to improve soils.
Beautiful segue. Nicely done. Skilled and masterful.
So in this episode, we're going to be making a transition from talking about the plants and the animals on the landscape to what's going on in the soil and how we can accelerate those natural processes, especially if we're thinking about something like, say, silvopasture, where we're trying to bring in new tree species and things like that into a site. We talked a bit about the microorganisms within the soil quite a bit in episodes 2 and 3, but now we want to take everything we've covered in the agricultural episodes and bring them back to the idea of building from the ground up. If we think about ecosystems, they operate similarly to a pyramid in that you've got biology in the soil, and that is the main function of a plant's ability to grow to its fullest potential. The minerals in the dirt are, of course, important, but in many cases, limit the capacity of what you can grow and how large it can grow, and the biology operates as essentially the throttle to the whole system, that they make everything accessible to the plants. So we're going to talk a bit about this process in this practice called Korean natural farming. The term Korean natural farming stems from the work of primarily Cho Han-kyu, or Master Cho. The fundamental insight of KNF, or Korean natural farming, is to strengthen the biological functions of every aspect of plant growth to increase productivity and nutrition. Biology then reduces or eliminates the need for chemical interventions, whether to protect against predation and competition with other plants. Further, KNF works to utilize traditional fermentation methods to make soluble nutrients and to keep the biology that is able to make those nutrients soluble alive until utilized on any farm or garden site. Natural farming like this was actually adopted by the South Korean government after successful trials growing rice in one county, where every farmer had followed this practice. They increased yields, saved money on inputs, and the rivers and coastal waters of the region had experienced massive environmental benefits. Now, there's two primary components of KNF, and today we're going to focus on the mineral component of KNF. We had brought up the pyramid that there's this basic nutrients within the soil, and it's the biology that can convert it into plant digestible nutrients. So the biology is incredibly important, but obviously it's necessary for the raw materials to exist within the soil, or the biology has nothing to work with. Fortunately, as long as there's dirt, there will be some minerals available. But what we can do with practices like KNF is to accelerate the natural restoration of these minerals within a specific site. Before we jump in, I do want to address one of my bigger concerns when it comes to Korean natural farming. There have been many folks who have taken KNF and, like any new field of study, really over-exaggerated its ability. We try not to fit into that and frame as much as we can within an evidence-based framework. So you may notice this episode has a ton of peer-reviewed research papers listed in the show notes section. Korean natural farming has a lot to offer us in the meantime, and our expectation shouldn't be to cast aside anything that isn't perfect, but to find positive things we can do that reduce destruction and accelerate our ability to heal our ecosystems. Additionally, it's incredibly cheap to do and is a really great way to get sucked into science in a way that's actually meaningful for what you're doing. There are unique benefits of KNF over, say, Jadam And there's better uses for one over the other depending on things like the length of your growing season and many more. And we're going to cover all that later.
Yeah, so Andy's been trying to get me to read about and make this stuff called LAB.
And drink it.
And that's what I said, and drink this stuff called LAB.
Oh, it sounded like you said read. So I'm telling you, it's good for you.
Yeah, I'm not drinking starchy rice rinse-off water flavored with sour milk.
You got to get down with the thick chunks.
I don't even like eggnog, so I don't know why you're trying to convince me to drink this.
It's like perfect for your body. And we're going to talk about that actually in the next episode.
Yeah, you said the same thing about mulberry leaves.
Yeah, and look at you. You're a fine specimen of a human being.
Yeah, this is why we have a podcast and nobody wants to see me.
You're swole now. Can't fit through doors.
I got a face for radio.
So I guess we should dive in. When we talk about Korean natural farming, there's essentially two goals: to create more sustainable nutrients in the soil for the biology and the plants, and to increase the amount of biology in the soil to accelerate the biology's ability to feed the plants more quickly. The first one is the one that I think is the easiest to understand, and it's where we're going to focus today. We talked about how there are a lot of nutrients often locked in the soil that plants just don't have the ability to access because the nutrients are insoluble, and that's why those relationships between the fungi, bacteria, and nematodes are so important. What we're trying to do is create soluble nutrients for the plants and those fungi and bacteria by breaking down various matter. This can include plants and other things like eggshells, oyster shells, bones, seawater, and more, depending on what you're trying to add to the soil. And shameless plug, if you haven't checked out our YouTube channel, we're compiling a collection of how-tos for many of these practices, and it's a really great, accessible way to make your soil more resilient in the face of climate change. The whole process is similar to what we've talked about with practices like intensive grazing and even fire management. We're trying to accelerate that nutrient return to the soil. While, say, bones and shells and rocks are made up of important minerals that our plants need, those minerals leach out naturally at an incredibly slow pace, in some cases thousands of years, and we don't have that kind of time, so we can use natural chemical reactions to accelerate this process.
Yeah, so I think we were talking about it before recording, but I made a joke about the whole KNF and the abiotic portion of it sort of being like probiotics for people, but it really does seem to do the same thing where there's specific bacteria and fungi and, things that are present in the soil that do the job of breaking down nutrients and making it available to other organisms. We have the same thing in our bodies, and trees have the same thing in their soil and dirt.
Yeah, and we'll cover that function of it in the next episode when we start talking about things like IMOs and all that good stuff. Today, we are focusing on the non-plant source of various nutrients.
All right, so it's the food. This is the food part of it, and then we'll study the breakdown part. So it's the sources of the nutrients, which will be broken down, and then the next part we're talking about, I guess, the players that do the breaking down and make things bioavailable.
Exactly.
Sweet.
So, we talked about, like, in nature, if let's just say a seagull grabs a clam and carries it out into the woods and drops the shell. How long is that shell going to take to break down? It doesn't really matter. And naturally, if a healthy ecosystem exists where things haven't been repeatedly removed from a site, because that's a process that happens repeatedly. For every shell that's dropped today, there might be one that's still on the ground from 100 years ago that is also breaking down. So there's no big bump in ebb and flow in terms of getting these chemicals back into the soil, things like calcium and so on. Because that doesn't exist today in a lot of ways, because of things like repeated clear cuttings and things like that, we have to think about how can we accelerate these processes of getting those things into the ground so the biology can take advantage of it. We're going to start with calcium. And calcium is not only the easiest to make bioavailable for plants, it's also the one that makes the most sense to someone who's learning about this for the first time. And calcium is a common substance, but the majority of it exists in the form of calcium carbonate, which can't be directly absorbed by plants. Adequate calcium prevents overgrowth, firms up the fruit, and prolongs the durability of those fruits. And in this process, it promotes the absorption of phosphoric acid and helps crops to accumulate and utilize the nutrients that are available to them. Water-soluble calcium, written often simply as WSCA, is produced by grilling and crushing cleaned eggshells and steeping them in vinegar until there's no bubbles present. The bubbles indicate the vinegar is reacting with organic matter to produce CO2. This process, using fire to break down the bonds within the materials and then treating them to a chemical reaction, is the process most common in utilizing any of these inorganic materials in Korean natural farming. The general idea is to isolate the inorganic material from the bonds with the organic matter and to make it bioavailable for quick utilization on your site. The added benefit of this process is that it also creates a lot of accessible material. A couple dozen eggshells can create enough water-soluble calcium for like a few acres for at least a year. Like I said, the practice is pretty similar once you cross different types of materials, and we'll touch on the different biotic materials you'll be looking to create into a soluble form. Generally, what you'll want to do is cook down the eggshells or clam shells or oyster shells, whatever you're using, until it's browned and breaks very easily, almost like it's charred, but not quite to that level. At this state, it's able to react with low pH, which is what vinegar is. So you add the vinegar to break those bonds and become water-soluble and ultimately plant-soluble in the process. At a ratio of 10-to-1 vinegar to that inorganic matter, the shells of whichever you might be using, mix them in a jar and watch the bubbles take off as the chemical reaction kicks off. One of the great things about these chemical reactions is there's really no negative if you start making it and kind of forget about it for a month or two. It's not going to make it any worse and might even make it slightly better. Generally speaking, these water-soluble minerals, whether it's this or the ones we're going to talk about, are diluted at about 1,000-to-1 ratio, which is about a teaspoon. It's actually technically a little less than a teaspoon per gallon of water, and are usually used as a foliar spray, which is just like spraying the leaves with like any kind of sprayer that you might have.
Yeah, spraying foliage.
Yeah, spraying foliage. Or as a soil drench, that is, watering the roots. Obviously, if you're drenching the roots, you're going to be using more of it, so that's something to keep in mind if that's how you want to use it. Most folks know they need calcium in their garden because the bottoms of like their tomatoes get nasty looking. And this is a really easy way to add it without like buying like terrible petrochemicals. Now, besides water-soluble calcium, another major nutrient that soils are often deficient in is calcium phosphate. Now, calcium phosphate is soluble in vinegar, but much less so in water. Calcium phosphate is available in bones, so it's a great way to recycle materials that otherwise end up in the trash, because typically people don't throw their bones from a steak or ribs in their compost. So this is one way that we can actually use them. Now, this is the same exact process as making water-soluble calcium. So what's the importance of calcium phosphate? When calcium bonds with phosphorus to create phosphate of calcium, the phosphate brings the calcium through the plant and drops it where it belongs. It transports all nutrients throughout the plant, with the exception of nitrogen. It's the major catalyst in all living systems, which means its presence is vital for many other reactions to take place in the plant, for many of those nutrients to get utilized. So, for example, it promotes more photosynthesis and ultimately a higher Brix. The phosphates not only help produce the sugar, but also bring it to the roots where it's excreted to feed those soil microbes. The microbes then make more nutrients that become available to the plant, so the plant can make more sugar.
Yeah, so just like people, plants need good, strong bones to help them grow.
Yeah.
You did mention one thing, though, which I thought was interesting, learning about KNF and the whole science portion of it, but the Brix count and the degree of Brix, it's interesting. What is it? Let's talk about it.
It's bricks, it's another bricks on the wall.
All right, so that's on par with your usual old, tired, and played out puns, but explain it.
I've been saving that for like 6 months.
It doesn't make it any better. It's not like wine.
You know what? I was told jokes get better with time, and I've been lied to.
Yep.
So we'll cover that in 1 second. But one thing I do want to talk about is in terms of all the soluble resources that we utilize in KNF, this one is probably the one with the least science or evidence backing of it. And that doesn't mean it's not necessarily true. It's just there's not a whole lot of evidence really confirming it. And partly I think this is because of the fact that it's focusing on a bonded nutrient that we can somewhat address by creating accessible calcium.
Yeah, so you baited me into doing this because I thought we were going to talk about acid and bricks in the wall, but I'm finding out that our conversations have entirely different meanings.
Hey there. Is your name George? Do you use foundations to funnel money to organizations to bypass tax regulation? Are you recognized as maybe funding radical leftist movements across the globe? Well then, this commercial is for you. Specifically you, George. My name is Andy, and the Poor Proles Almanac is looking for you. Come fund our program. We've got boomsticks. We collectivize the energy of the sun with plants. If this sounds like an ad made explicitly for you, go support the Poor Proles Almanac at poorproles.com.
So you never actually explained anything about Brix or degrees Brix, or at least I don't think you did.
Yeah, so degrees Brix, or Brix for short, measures the level of sugar or sucrose in any produce. A refractometer is the tool that's used to measure the Brix level, and the higher the degrees, the sweeter the bite, supposedly. The scales differ based on the produce being measured, but that shouldn't be a total surprise. Like a tomato is going to have a different Brix level than lettuce or whatever it is they might be measuring. But the general idea is that the higher the Brix, the less water saturated a food is, and by proxy, the more full of, well, other stuff, usually meaning good stuff, that your food has. So more phosphorus, specifically when it can bond with calcium, can help process and store more sugars and other nutrients. Now, Brix isn't just reflective of sugars, but all non-water solids within a specific plant, fruit, or whatever. However, carbohydrates, for example, can impact a Brix number more significantly than like a large number of vitamins that you might be specifically looking for because of the fact that it's just a small amount. For example, because of the simple fact that there's much less vitamins in something than sugar. So theoretically, you could change growing conditions to double the amount of vitamins, but you might not see a significant change in the Brix reading because you'd only be talking about something that's like 1% of the non-water content. And this is true for most minerals. The biggest factor on Brix is really water. More water means that a sample will be diluted. So while a lot of folks will point to increased Brix readings as evidence of more nutrition or a healthier plant, that's not necessarily the case. If you don't water a tomato plant for a couple days, the Brix reading is obviously going to be higher than the actually like healthy tomato. Is the dehydrated tomato healthier for you? No, just dehydrated.
It's the nutrient density of food, but only in correlation with how much water is in there.
Yeah, assuming that the water level is appropriate for the plant, then you can get better side-by-side comparisons. So, for example, it can be really helpful to use a Brix reading when you're trying to understand a plant's ability to store energy when comparing two plants that are near each other with, say, similar soil types that might be getting managed in different ways. So you might have two tomato plants 5 feet away from each other, and one is being treated with traditional fertilizers and the other one is being given K&F. And if you pick two tomatoes that were watered the same and all of the other things, that Brix reading will tell you a little bit about how those different factors might have impacted the quality of fruit that you're getting. Now, while Brix readings are important or can be manipulated by things like lack of access to water, there's a lot of research that's been going on showing that lower Brix levels are often tied to things like low phosphate levels, while appropriate Brix levels, according to that specific plant species, can indicate things like relative immunity to bacterial, fungal, and insect attack. And not only this, but often low Brix flowers will get visited less often, if at all, by pollinators because it's just not worth the effort for the pollinator.
Okay, so here's one of your puns. I think we've put enough bricks in that wall.
You know what? So the last soluble amendment I want to talk about is water-soluble potassium. This shouldn't be a surprise since we've covered 3 of the 4 main nutrients that we think of when we talk about plant amendments. NPK is nitrogen, phosphorus, and potassium. The 4th one usually referenced as calcium for the reasons stated above. We haven't covered nitrogen, but don't worry, we're going to get there. As for water-soluble potassium, the process is pretty similar, again, to calcium and calcium phosphate. We char these thick green stalks, typically tobacco or sunflower or cannabis stalks, but there's probably a lot more that could be used. And we break them into small pieces that can be stuck into water at a 10-to-1 ratio for a week. Again, it's that same ratio, except now we're using water instead of vinegar. After that week, we're going to strain it, and again, use it at that 1 teaspoon per gallon or 1 to 1,000 ratio. Potassium is associated with the movement of water, nutrients, and carbohydrates in plant tissue. It's involved with enzyme activation within the plant, which affects protein, starch, and adenosine triphosphate, or ATP, production.
ATP in the house.
The production of ATP can regulate the rate of photosynthesis, and potassium also helps regulate the opening and closing of the stomata, which regulates the exchange of water vapor, oxygen, and carbon dioxide. So, yeah, important stuff.
Plants don't actually move, but the parts of them that do, it's all done with ATP.
Yeah. Is that something you learned from weed school?
No, that's actually from freshman year of biology in high school before I went to sleep.
I never took biology.
Yeah, I took bio.
I really don't think I was supposed to graduate. I think they screwed up.
Yeah, you took a bunch of math classes, over again. You didn't do sciences, because I remember you had 2 math classes one semester, and you didn't have science. So they definitely botched your education. But hey, that's public school, man.
Oh, 100%. Freedom.
Yeah, now that I think about it, you took 1 science class in high school.
No, I took 2. I took earth science and environmental science. How those weren't the same things, I'm not sure, but they weren't.
Yeah, you did. You never took science in high school. I'm just thinking about that now. That's hilarious.
And environmental science was literally during lunch. So what we did is we collected the recycling bins, and that was the class.
Yep, I remember that. Oh man, public school was so fun.
It's such a joke.
All my teachers were drunk.
It was great.
The bus drivers were drunk.
The best time of my life. It would have been amazing if I learned all this stuff in high school, but here I am having to do it on my own.
Yeah, I was going to say, look at you now. I learned this way back in the day, and you did it just because you wanted to. That's pretty admirable.
Like a fine wine, Elliot.
Yeah, they had to hold me down into a chair and force this into my brain. And I fought it every second, every minute I could.
And here we are. You're answering all my questions and digging deep to get those memories.
I did good. We're doing good.
So we're going to cover a bit about nitrogen, partly using one technique, but also partly in another episode because it's a bit of a complicated process, also related to some of those biotic amendments. With all that in mind, we've found solutions to address many of the challenges of amending soil in terms of the main nutrition that plants need to be successful.
Great. Well, that was a short episode. Good job.
Oh man, we're just getting going.
Honestly, you've painted a picture for me as a mad scientist, but you're just rooting around in shit and vinegar, garbage and vinegar. Not shit, but trash, food scraps and vinegar.
Yeah, that's absolutely true. But maybe also I'm a mad scientist.
I guess. You had the hair for it.
I did. I shaved it all off.
It looks good. Good haircut, buddy.
Just trying to be a normal member of society.
It looks like it could pass until they start hearing the podcast.
Probably. So obviously, these different byproducts of other living things that we've been talking about aren't the only way to get minerals returned to the soils, but we can use things such as rocks, which contain trace minerals, which can be used in particular for things like long-term mineralization of soil. This is probably one of the more intimidating processes because we often think that, most of the rock in my soil comes from massive boulders, which would mean it's pretty homogeneous, right? Also, maybe not.
That's a very you answer. So yes and also no. Thanks, Andy. So helpful.
I'm nothing if I'm not consistent. So you can use a local geological survey map to help identify the minerals below the ground surface. These types of maps will specifically identify the rock types in your area. Now, if you've done a soil sample, you should be familiar with what's already on your site, and comparing these results with the rocks that show up in your geographical survey can really offer a unique opportunity to see what's available locally that can help improve the mineralization on your site.
So you're saying to pick up a bucket and go elsewhere and throw some rocks in it and bring them back?
Sort of. So depending where you live, it's worth checking out to see if there's any quarries nearby. These sites are particularly useful because they build up rock dust from crushing rocks and cutting countertops and things like that. And they're often happy to see someone take some of it for free. Like I said, this doesn't mean take any and all rock materials because you may not need what's available. This is just the first step in trying to find out what's available nearby as first choice to adding those choice minerals. You can always buy rock dust, and many of them are commonly available online, although expensive to ship because, rocks. Now, if you're struggling to find a geological survey map from the United States Geological Survey, the USGS also released a paper called Element Concentrations in Soils and Other Superficial Materials of the Conterminous United States, which is linked in the episode notes that provide a bunch of information about mineral content of the soil at the state level.
Yeah, it's a good coffee table read.
Yeah, casual, It's what I like to read before I go to bed. So how do we add these to the soil? If we do have access to, say, crushed stone dust to add, we can add the dust particles right into our soil surfaces. Even better, if you have a large pile of compost, adding to the compost is great as well because in order for the minerals to become available to plants, It's necessary for the soil biology to start digesting and breaking down those rock dusts, which is unsurprisingly a slow process. Much like adding lime to your front yard might take 6 months to impact soil pH, those rock dusts also take quite a while to make a difference. So, in the same vein as rock minerals, silts and clays also offer unique benefits depending on the site in particular that you're working on. Of course, when it comes to taking silts in particular, it's important to be aware and really thoughtful about how much you're removing from the site, since silts are particularly important in places like river basins and ponds. It's also important, if you can, to consider doing a soil analysis of the silts to see what minerals are present. And of course, if you live someplace like the Northeast United States, to make sure heavy metals aren't collecting in the silts.
Thanks, America, the place where I can love heavy metal and not love heavy metals.
And eat mercury. I love a little mercury in my garden.
I had a mercury thermometer scare when I was younger. It was cracked, and I was using it, and I put it down on the table. My mom watched me, and it broke. And that quicksilver just ran all over the table. And I thought it was cool. She was freaking out. She was like, "That was in your mouth." I was like, "Yeah, cool."
That's awesome.
It's a Capri Sun. She was like, "You're going to die." And then I got real scared.
Cool. And you're still here today. So thanks, Gwen.
I'm fine. And that constant humming in my ear, it's just part of life now.
There you go. Small victories.
I think I got mercury poisoning.
Explains a few things.
It does.
So silts are often loaded in things like nitrogen and anaerobic bacteria that will quickly break down when added as an amendment to topsoil, releasing a lot of nutrient-rich, easily digestible nutrients to your soil. Harvesting silts are one of the most ancient farming amendment practices in human history and is really a core piece of how annual agriculture came to be. So don't miss the opportunity to utilize this ancient practice if it's available to you. Now, further on the opposite end of the spectrum in many ways are the harvesting of clays for your soil, especially if you have like naturally sandy soil like I do. We've talked a bit about how sandy soils drain well, but the downside is that minerals and nutrients are easily washed away because of the large particle size of the sand grains, which allow for really easy loss of material. Well, that process is actually a little bit more complicated. There's a measurement system called the cation exchange capacity, and it's a measure of a soil's ability to hold positively charged ions. And I promise I won't make this too complicated. As Elliot said, I didn't do great in science, so if I can understand it, anyone can.
Yeah, he's going to try to simplify cations, not anions. So go ahead and try. Explain it to me like I'm 5 years old.
So with clay soils and soils with high amounts of organic matter, these soils have negatively charged sites on their surfaces which absorb and hold positively charged ions called cations by electrostatic force. Remember back in high school the positive and negative ions? I don't, but I've been told that's what's covered.
Cations and anions.
This electric charge is super critical to the supply of nutrients to plants because many nutrients exist as cations, potassium and calcium being two we've already covered. In very general terms, soils with large amounts of negative charge have more nutrients because they retain more of these positively charged ions. Now, this all ties into a larger conversation on balancing soil pH, understanding why sandy soils struggle so much, and so on. I think we might have mentioned way back when we did the soil episodes that clay soil actually has a slight magnetism, and this is part of it. Increasing the soil's cation exchange capacity by increasing the organic matter or by adding clay to your site, whichever is more accessible, helps to build that capacity to retain nutrients, both by reducing the ability of water to flow through the site, using smaller grained clays and organic matter, and by increasing that electrostatic force. I'm not going to get too much deeper into this, so I think I'll stop there on the cation exchange capacity.
Perfect, because that was right around the point where a 5-year-old would have gotten bored and played with something shiny.
I mean, yes. Although my son just...
Yeah, we was trying to explain the event horizon to you. It's pretty awesome.
Yeah, he was all about the event horizon, and I think he might be depressed. I'm not sure. Might have to check in on that.
You can make him watch the movie, and he probably won't sleep for a week.
Oh, he's accepted death.
That movie was scary as hell, man. Back when I saw it the first time. It's probably not scary now, though. Pop culture.
Hey, thanks for tuning in to the Poor Proles Almanac. This is Andy, reminding you that if you're looking for more content outside of the scope of the podcast, or sources, recommended readings, or ways to support us, you can find that at poorproles.com. Further, we've expanded our delivery into video content on our YouTube channel, where we're able to show step-by-step how to do many of the processes that we talk about within the podcast. We have also started a Twitch channel where we platform various folks on skills from DIY mushroom production to the various methods to keep land out of the hands of developers. Again, all this can be found at porkbowls.com, and we look forward to seeing you over there. Now, if you live near the ocean, there's an incredible amount of resources available for soil amendments, starting with the ocean water itself. Seawater can be diluted and applied to our soils, pastures, and even the plants themselves, as the water is rich in trace minerals. Typically, seawater is diluted at a 50-to-1 ratio, so for every cup of seawater, you'll mix with 50 cups of rainwater. This can be sprayed every few weeks if possible, and there's a bunch of different ways the water can be utilized. And this is something we'll be going into detail on our YouTube channel as we continue to upload more and more content up there.
Yeah, that's right. You heard it here, folks. Soon you'll be able to watch us collect seawater and watch Andy put it in a bucket and then transfer it from a bucket to a pot and boil it. It's really good content. You guys are going to love it.
Yeah, I mean, we take water, we put it in buckets, we boil it. I mean, what else would you want?
It's Andy talking over him boiling water. It's amazing. It's good stuff. You're going to love it. Trust me.
You know, top tier. So not only can we use the seawater, we can harvest salt from the ocean and use the salts to create things like salt licks or just to like feed ourselves. And while this isn't really necessarily a KNF thing, there are those micronutrients that are available when you harvest the sea salt yourself versus it being mined someplace else that are really useful. And if you have access, go to the ocean, go get it yourself. And go watch our salt making video if you really want to see it.
Yeah, gotta respect the hustle. The salt making video is part 2 of the water boiling video.
And the added benefit is you get to watch Elliot chase some razorback clams.
Those slippery bastards. I was picking seashells out of my fingertips for days. And then we got to watch the footage again because I wish I had brought salt. It's all I needed.
Get them slimy boys.
And they were not slimy. They were tender and delicious. And I did pretty good on the presentation as well.
A for effort and A for cooking. And when you're done eating them, you can crush their shells and break them down into water-soluble calcium, like we said earlier. We can also use seaweeds that you can harvest and even any fish byproducts if you happen to catch fish and utilize them into fish amino acids.
So like vitamins or like the stories of the indigenous people when they would bury corn seeds with fish, like racks, fish heads and fish racks?
Yeah, sort of, but also no. So fish amino acids are processed using brown...
Wait, did you just yes and no me again for the second time in one episode?
I only yes and no you, first off.
Good.
So,
good Lord, man.
You're going to call me the yes man, the yes and no man.
You're a maybe man.
Yes, but also no.
Mr. Maybe.
Mr. Maybe. In the next episode, we're going to talk a little bit more about utilizing brown sugar as a tool in Korean natural farming and why we use brown sugar instead of other sugars. But generally, it's utilized at a 1-to-1 ratio by weight with whatever you're using. In this case, we're talking about fish chunks and guts and fish eyes and all that cool stuff.
Fish byproducts?
Yeah, all the fish byproducts. And you'd want to chop the fish up into chunks and mix it all together so everything is completely covered in brown sugar. You'd put that in a bowl or a box until it's like 2/3 full. And then you'd want to cover the top with a layer of more brown sugar, which will form essentially like a cap. And as it dries out, it'll reduce any risks of outside contaminants getting in. If you have homemade compost or an IMO4 available, add a handful of that to the top, and this will help accelerate and eliminate some of the smells of the fish breaking down. Cover this whole thing with a cloth and let it ferment for like 6 months in a dry, well-ventilated room at ballpark room temperature. If it's going to be cooler, that's fine. It's just going to take longer. After about 6 months, you'll see that there's a liquid that's collected at the bottom of the bowl, and that's your fish amino acid. The rest of the fish can go in the compost, or you can do a vinegar extraction to help isolate some of the other nutrients in the fish as another amendment. In a few weeks, we're actually going to be interviewing Nigel Palmer, who has actually dedicated the past few years towards cataloging exactly what's in many of these different extracts, so that we can continue to build that scientific framework for these resources, and in doing so, better apply them.
I love how he gave you a tip for reducing the smell, as if that's not going to smell like exactly what it is.
Oh, it doesn't.
That's hilarious to me. I don't believe you.
I've made some. I literally kept it in my living room. You couldn't smell it at all. You've been at my house when we've had it in my living room and didn't even notice.
Yes, I did. I was like, it smells like a rotting dead fish covered in brown sugar.
It does not smell like anything.
I said it in those exact words, and now we're doing this episode.
No. Bullshit.
That never happened. But I do want to address one thing. I think we talked about it before recording. I'm not sure if we did it in this episode, but KNF is littered with acronyms, and they just throw them around all willy-nilly without explaining them. And a lot of the stuff that I was reading, and you just used another one, IMO4, and I just watched the Star Wars movie, and it sounds like a droid. So are we going to start explaining acronyms, or are we just going to have people Google all this after?
You got to do your own homework. Google it. No. So IMO is indigenous microorganisms, and there's a process of harvesting them and then essentially breeding them to apply where you need them. And it goes through stages of 1 through 4 or 5, depending who you ask, or even 6 if you ask certain other people. And again, that's something we'll show on our YouTube. And actually, in the next episode on KNF, we will be covering all of those, what I call like the live KNF, whereas at this point we've been talking about mostly like mineralization and stuff like that. So I think understanding this component is really helpful to understanding the next component, because this is a little bit easier and then you have a better framework to understand what's going on in those other steps. But to circle back to fish amino acid, or FAA.
Another acronym.
Those acronyms are just coming for you.
FAA.
So you store all that and it doesn't smell, and then you harvest the liquids at the bottom of the fish amino acid. And much like all the other things we've talked about, it's applied at a 1 to 1,000 ratio, or a little less than a teaspoon per gallon. And if we think about what a fish is, really, it's mostly protein. It shouldn't be much of a surprise that FAA is pretty much like a super nitrogen-dense fertilizer. The Republic of the Philippines Agricultural Training Institute actually lists the liquid drained from this process as 90% nitrogen, 2% and 2.5% phosphorus, which is, well, pretty wild. I mean, it makes sense when you start thinking about it because of the fact that we do take 1 teaspoon per gallon of water from this process. And if you have to dilute it that much, it should be pretty strong. Now, with that example, I haven't seen a secondary source where that research came from. It's from an old pamphlet. But I thought it was really interesting, and it kind of makes sense in terms of, again, how we dilute it.
Yeah, and it brings us back to our conversation about the protein in mulberry leaves and how they're high in nitrogen, which translates or can translate to protein function.
Exactly.
Protein synthesis.
Yeah, if you haven't listened to the episode we just did recently on tree hay, we talked a little bit about the relationship between nitrogen and protein. So if you're not from an agricultural background, you might not know that relationship. But essentially, nitrogen is a building block of protein. So if we understand that protein requires nitrogen to exist, if we take something that's high protein and break it down, it's going to have a lot of nitrogen. And that's kind of what we're seeing play out with this fish amino acid. Now, fish amino acid isn't the only amino acid that we can harvest. So, for example, if you butcher a chicken or 10, like myself, and you're not a huge fan of eating their livers, liver amino acids are also another smaller scale alternative to fish amino acids. And of course, this speaks to the opportunity to experiment in the KNF field, as I couldn't really find any papers on the nutritional breakdown of liver amino acids. But given that liver is probably as close to a superfood as exists on the earth, sorry vegetarians, I have to imagine the spectrum of nutrients is probably incredibly beneficial. So like liver is super high in protein, so it's going to provide a ton of nitrogen. And ratio-wise, it's actually probably higher in potassium in comparison to fish. So needless to say, there's a bunch of opportunities to start thinking outside the box and really start experimenting. You just have to have a key fundamental understanding of what the idea and the concepts behind Korean natural farming are. So in this episode, we've focused primarily on abiotic ingredients, which is probably the less commonly discussed side of Korean natural farming. And part of that decision to start here was because, again, I think it's a lot easier to understand. Now we can essentially take that framework we've discussed here and apply it to the fermented living material and plant extracts that we'll dig into in the next episode. So in that next episode, we'll be talking more about the brown sugar application, harvesting those indigenous microorganisms, and maybe even getting some of the more sciencey stuff like paramagnetism. And like I said, we're going to be linking to a bunch of resources in the show notes. And while all this stuff wouldn't be necessary if the landscape had been managed appropriately, for the last hundreds of years because of the current dire state of things. It's really important to start thinking about how we can accelerate changing our soil into something healthier. And that requires that we take some of these additional steps to accelerate getting those nutrients and all those minerals available for our plants and our entire ecology over the long term. So hopefully all this made sense, and now you all have some understanding of the acronyms that you see around the Korean natural farming field, and they're starting to mean something to you.
Yeah, so I noticed the last time we did call some of your chickens, we tossed out the hearts and the livers. And I have a couple of recipes where we could use those, especially the liver. I do love Cajun dirty rice, and traditionally it's made with chicken liver, and it's really, really good. And if you don't tell people that it's chicken liver, I tell a lot of people that it's ground beef, and it's not. But it's really tasty, and I mean, it's not wrong. They all eat chicken. It's hard to tell people that it's chicken liver, especially in the presentation. It's just delicious, and it's good with Lowry's, and it's good with hot sauce. And you know what? I could probably even sneak a couple mulberry leaves in there, and it would still taste good.
Look at that. You've come so far. Can't wait to bring out LAB next episode and see you chugging a glass of it.
Not gonna lie, you break me down just like KNF does. I start off strong and hard, and over time you wear me down, man. You break me down.
Accelerate the breakdown process of Elliot.
It feels like I'm dying.
I'm gonna fertilize you back in my plants.
I'm decaying while alive. It's amazing.
Amazing. So hopefully you guys enjoyed this episode.
I was gonna say, from two rotting meat bags to the rest of you, thanks for listening. This is the Poor Pro's Almanac. I'm Elliot.
And I guess I'm Andy for now.
Yeah, sign off, fool.
Bye.
Bye, guys.